My name is Partha Ghosh and I am currently working in the capacity of an associate professor in the Department of Physics, Bangladeshi College. It is an affiliated undergraduate college under Calcutta University and is one of the oldest institutions in this region, having a legacy of about 135 years. About me, I was born and brought up in the still city of Durgapur. Did my bachelor's with honors in physics from Durgapur Government College in 1994. After that, I pursued my MSc from University of Bardhaman with specialization in nuclear and high energy physics. Upon clearing CSIR NET, I joined Variable Energy Cyclotron Center, Department of Atomic Energy, Kolkata as a junior research fellow in September 1997. I was working under the supervisorship of Dr. Yogendra Pathak Vyogi, who was then the project manager of the CERN India collaboration. Subsequently, when I was testing some detector prototypes at CERN sometimes in July 1999, I got to know via email that I had been offered a lecturership at Bangladeshi College. I had appeared for the interview of West Bengal College Service Commission before coming to Geneva. I had to rush back to Kolkata to join college in August 1999, and as it was quite a particular necessity of that moment. I was 26 years of age at that time and become a full-time faculty member and a part-time researcher. As all of us would agree, research requires complete dedication and I was desperate to work upon my PhD. Since there was neither any access to experimental data nor I had any computer at home or college for myself, I could go to the institute only on college holidays and vacations. Finally, in 2005, I was allowed by the college to apply for a sabbatical under UGC Faculty Improvement Program. Things were more or less ready by then and I could wrap up my PhD thesis in just about an year. After going back to college, I have been teaching since then and will be completing 23 long, eventful years of my profession shortly. I have a tendency to switch my teaching assignments within the prescribed syllabus with my colleagues every 3 to 4 years. I have taught properties of matters, waves optics, electricity, magnetism, electronics, statistical mechanics, nuclear and particle physics earlier. Currently, I teach core classical mechanics to first semester, core quantum mechanics to fourth semester, discipline-specific astrophysics to fifth semester, and nonlinear dynamics to sixth semester students. Teaching new topics provide me with the so-called adrenaline rush every time I do so. About my work, my research area was primarily focused on searching for experimental signatures of quark-gluon plasma, or QGP in short, in high-energy heavy ion collisions. It is a state of matter into which the neonatal universe was believed to have evolved just a few microseconds after the Big Bang. Heavy ion physics thus have an overlapping between both particle physics and astrophysics cosmology. Study of QGP is important in the sense that it can throw light upon the actual process of evolution of the universe as we see it today. Many unknown questions regarding the theory of strong interactions or quantum chromodynamics are yet to be answered. Theorists working on QGP are looking into it nowadays through some exotic events that are formed during ultra-relativistic heavy ion collisions. These are known as disoriented chiral condensates, or DCC as we call it in the community. Examining the evolution of the QGP phase may also lead us to tread beyond the standard model. Also, some open questions like the hierarchy problem in cosmology can be addressed. My group at VECC has been constructing photon multiplicity detectors that are being used at various experiments at CERN, GSI, Darmstadt, RIC, etc. I had myself worked on the simulation of the ALICE PMD that is now being used in the Large Hadron Collider LHC. The analysis section of my work was upon the data obtained from the WA98 experiment in the CERN Superproton Synchrotron, or SPS. The photon multiplicity detectors that we have been building since then are improvised day by day, and now much more efficiency has increased. The efficiency has increased a lot. We had used silicon pads earlier, now we use scintillation pads, gas detectors, with cutting edge electronics and computational techniques. Collision experiments with heavy ions take place at very high energies, at giga or tera electron volts, large enough to disrupt the stable structure of protons and neutrons. Quarks and gluons inside them are set free, and these mini bangs replicate the Big Bang in many ways. The QGP phase is obtained for a very short period of time. Upon subsequent cooling and thermalization, the elementary particles emerge out of the collision area carrying valuable information about the system. Photons are one such probe which we study at VCC. The multiplicity, pseudo-rapidity, energy, azimuthal distribution of the photons, all such properties are recorded in trillions of events. I had performed event by event analysis of the data obtained from experiment, filtered out the statistical noise by some new means, compared the result obtained with simulation. Some exotic events were obtained with some new physics in it. I had tried to obtain an estimate of the degree of thermalization of the QGP at SPS energies. It was primarily the work of my PhD thesis. It was indicative of the fact that those techniques developed would lead us to understand much more physics at higher energies. As you all have known, the Sun LHC has reached an energy of 13.6 tera-electron volts on 5th July 2022. I, along with the fellow researchers in my group, are excited to know what new realm of physics is about to be unveiled in the forthcoming days. Coming to the next important part, I had completed a UGC minor project well back in 2011-12, and the work was primarily on physics teaching. I had explored whether basics of string theory can be incorporated in the UG curriculum as done in the US universities. The idea triggered in my mind while I was teaching particle physics in one of my classes. It was a third-year class. Students had already an exposure to special relativity, Lagrangian mechanics, quantum mechanics. Till then, I had no exposure to the mathematical framework of the theory, and I could not be satisfied myself with my answer asked to the questions asked by the students in the class. After quite an exercise and execution of the project, it came out that indeed this topic can be offered as an advanced elective paper in the final year. If one enjoys knitting one theory of physics with another, quantization of strings would come out quite naturally if the student is mathematically inclined. We have started teaching discipline-specific electives in the CBCS curriculum, and I sincerely hope that in the new scenario of the National Education Policy's 4 years UG program, these shelved findings like mine may be implemented as well. We'd be able to teach much more advanced topics to the students who are interested and thus boost up their motivation to pursue research. So we had been learning some standard one-dimensional quantum mechanical problems. তো আজকে যেটা আমরা করব, আমরা খুব ছোট দুটো প্রবলেম একটু আলোচনা করে নেব, হ্যাঁ, খুব ছোট ছোট কতগুলো প্রবলেম। আমরা এরপরে 1Dর পরে we would move on to 2D and then to 3D problems of quantum mechanics. So this is the first problem. A particle is constrained to move on a ring in one dimension. তো দেখো এখানে আমি একটা রিং এঁকেছি, রিংয়ের রেডিয়াসটা হচ্ছে r। তো যেহেতু সাপোজ আমি এই ডাইরেকশনটা হচ্ছে ইনক্রিজিং থিটা ডাইরেকশন, তো আমি যেটা করব সেটা হচ্ছে, তুমি নিশ্চয়ই বুঝতে পারছো যে ওয়ান্স ইট কভার্স দ্য অ্যাঙ্গেল 2π ইট কামস ব্যাক টু দ্য সেম পজিশন। তার মানে ইফ I represent the wave function of the particle to be psi, the periodicity is psi of theta plus twice pi equal to psi theta, and আমি যদি এখন মানে লিনিয়ার ডিস্টেন্স কভার করাকে if I denote it by x, then periodicity would again imply psi of x plus l equal to psi x, where l equal to twice pi are the circumference of the circle. আশা করি এটা সবাই বুঝতে পেরে গেছো। তো এইটা হচ্ছে আমার কন্ডিশন, এটা বাউন্ডারি কন্ডিশন। তো the particle is free to move when it is on the circle, but it has infinite potential outside, মানে সার্কেলের বাইরে পার্টিকেলটা বেরোতে পারবে না, এই রিংটার বাইরে পার্টিকেলটা বেরোতে পারবে না। সো আমি যদি ধরে নিই যে পার্টিকেল ইজ কনস্ট্রেন্ট টু মুভ ইন দিস রিজিয়ন, আমার শর্ডিঞ্জার ইকুয়েশনটা হবে, শর্ডিঞ্জার ইকুয়েশন ইজ মাইনাস h ক্রস স্কয়ার বাই টুয়াইস m d2 psi dx2 equal to e psi. This is my Schrodinger equation. X is distance traveled, আমি এই কন্ডিশনটা ইউজ করব। আর এটাকে লেখা যেতে পারে d2 psi dx2 equal to e psi. Okay, so d2 psi dx2 equal, just ঠিক আছে, let's move on to the next one. আমি যেটা নেক্সট বার যেটা করব সেটা হচ্ছে আই প্রি মাল্টিপ্লাই দিস ইকুয়েশন। আমি এটাকে প্রি মাল্টিপ্লাই করব psi star দিয়ে। If I pre-multiply this by psi star, so I have psi star here and e psi star psi here. I hope this is understood. আমি এবার জাস্ট প্রিমাল্টিপ্লাই করে নিয়েছি। এবার আমি যেটা করব সেটা হচ্ছে আমি যেটা করব সেটা হচ্ছে আই উড ইন্টিগ্রেট ইট ফ্রম 0 to L, মানে স্টার্টিং পয়েন্ট আর এন্ড পয়েন্ট 0 to L আমি এটাকে ইন্টিগ্রেট করব। সো মাই ইন্টিগ্রেশন বিকামস মাইনাস এইচ ক্রস স্কোয়ার বাই টুয়াইস এম minus h cross by twice m integration psi star d2 psi dx2 dx 0 to L equal to e integration psi star psi dx 0 to L. Wave function is normalized, so right hand side just gives me e. Right hand side just gives me e. Integrating over the whole region, the total probability is 1, and so right hand side is e only. আচ্ছা, এইখানটা যেটা রয়েছে মাইনাস এইচ ক্রস স্কোয়ার বাই টুয়াইস এম ইন্টিগ্রেশন 0 to L, দেখো তো এটাকে লেখা যায় এখানে এরকম মাইনাস এইচ ক্রস স্কোয়ার বাই টুয়াইস এম ইন্টিগ্রেশন 0 to L d of psi star, sorry, d dx of psi star d psi dx minus d psi star dx d psi dx. এই টোটাল জিনিসটা ইন্টু dx ইকুয়াল টু e। কিছু না, আমি যদি psi star d psi dx কে ডিফারেন্সিয়েট করি উইথ রেসপেক্ট টু ddx, আমার কাছে কি আসবে? প্রথমবার একটা psi star d2 psi dx2 আসবে, আর তারপরে একটা d psi star dx d psi dx আসবে। আমি ওই টার্মটা ওটা থেকে মাইনাস করে দিচ্ছি, আই ফাইন্ড দ্যাট দিস অরিজিনাল টার্মস কামস আউট। সো দিস ইজ ভেরি ইজি। ইন দ্য নেক্সট স্টেপ হোয়াট আই ডু ইজ সামওয়াট লাইক দিস। আমি যেটা করব, আই the first term to be minus h cross integration 0 to L. Notice যে এখানে ddx আছে, এখানে dx আছে, so this is d of psi star d psi dx plus h cross square by twice m, এখানে আমি লিখব d psi dx mod square equal to e. Now এখানে একটা d আছে, এখানে একটা integral sign আছে, so this differentiation and integration would cancel out each other, and basically I am left with minus h cross square by twice m psi star d psi dx plus h cross square by twice m integration d psi dx mod square equal to e. মজার ব্যাপারটা হচ্ছে যে এইখানে যখন আমি ইন্টিগ্রেশনের লিমিটটা বসাবো, যেহেতু psi at 0 is equal to psi at L, means if I put x equal to 0 here, psi at L equal to psi at 0, so psi star also same value হবে, so this term basically cancel out. এখান থেকে আমি একটা খুব ইম্পর্টেন্ট জিনিস পাচ্ছি। আমি যেটা দেখতে পাচ্ছি হচ্ছে দ্য এনার্জি অফ দ্য পার্টিকেল ইজ মাইনাস এইচ ক্রস স্কোয়ার বাই টুয়াইস এম ইন্টিগ্রেশন 0 to L mod d psi dx equal to 0. নাও এই ইকুয়েশনটা দেখে এটা তো আমাদের কাছে, এটা দেখো সবাই বুঝতে পারছো কিনা, এটা নিশ্চয়ই সবাই বুঝতে পারছো যে দ্য এনার্জি ইজ আ পজিটিভ ডেফিনিট কোয়ান্টিটি। দ্য পার্টিকেল ইজ বাউন্ড, obviously the particle can never come out of this 1D well, 1D well in the sense যে ও কখনো ওই রিংটার বাইরে বেরোতে পারবে না। এনার্জি ইজ নট নেগেটিভ, the energy is a positive definite quantity. Now আমাদের what we need to know that what would be the values of energy and how the wave function look like. So boundary condition apply করলে আমার এনার্জিটা যে পজিটিভ ডেফিনিট সেইটা আমি একটা ইনফারেন্সে পৌঁছলাম। সেকেন্ড ইনফারেন্সটা আমি আসছি। Let us have a trial solution somewhat like this. Trial solution, so আমরা সবাই জানি যে ট্রায়াল সলিউশনগুলো আমরা নর্মালি এক্সপোনেনশিয়াল নিয়ে থাকি। e to the power psi say is n is a normalization constant, e to the power I k x. Let this be the kind of trial solution which we would try and find out what physics is coming out of this. So psiটা এরকম দাঁড়ালো, so আমি এটাকে psi x লিখি, so psi x plus L is supposed to give me n e to the power I k x plus L, and that is equal to n e to the power I k x from the boundary condition which we have already considered at the starting of the problem. So this gives me e to the power I k L has to be equal to 1. So k must be equal to twice n pi by L. N is an integer starting from 0. So if I have these values of L, these values of k, I would find that a periodic boundary condition to satisfy hoche. Very good. So what's next? Let me do one thing. I put a small k in here. I put a small k in here. And for a free particle, means the particle is supposed to be free when it is moving in the circle. I would come back to a very important point now. So what would be the energy? The energy is supposed to be h cross square k square by twice m. It is nothing but p square by twice m, and p equal to h cross k, k is the wave number, I suppose. So putting this value of k here, I would have h cross square into 4n square pi square by twice m L square. একটা 2 কেটে দিলাম, and আমি যদি if I put L equal to twice pi r, I have En, putting the value of L to be twice pi r, I have the value of energy to be n square h cross square h cross square by twice m r square. Just putting in the value of L equal to twice pi r. Now this is a nice thing. Energy of the particle is n square h cross square by twice m r square. Another thing which comes out is that the wave function, apart from this normalization constant, well, we can do normalization and find out the value of the normalization constant, and I would find out very easily. এগুলো তো আমরা আগেই করেছি. The normalization constant comes out to be 1 by root L. So the final expression for the wave function of this particle is 1 by root L e to the power I. k এর জায়গাতে আমাকে লিখতে হবে twice n pi by L, twice n pi by L x. This is the wave function psi x. You can as comfortably you can put the value of L to be twice pi r. That is fine. মজার ব্যাপারটা হচ্ছে যে I haven't talked about it is an integer. I haven't talked about what kind of integer. Is it a positive integer or it is a negative integer? And what about 0? This condition k equal to twice n pi by L, so that I get e to the power I k L equal to 1, requires that k has to be k can be 0, k can be plus minus 1, plus minus 2, plus minus 3, etc. Now how do I interpret the negative values? There is no problem. If I consider that the particle is moving anti-clockwise, and for these cases ওই n এর ভ্যালুগুলো for different configurations or different energies, if I can choose it to be positive, then the particle can as well move in the opposite direction, in the clockwise sense. Under that circumstances, I will call the values of n to be negative. So I find that all the energy levels are doubly degenerate. You can have a positive value of n, and also you can have a negative value of n. What about 0? 0, n equal to 0 would make the particle to be stationary. So we will physically, when we consider physics, we will discard this solution. We will discard the n equal to 0 solution, and we will find that the energy eigenvalues are doubly degenerate, and it starts from n equal to 1. It starts from n equal to 1. So this was the first problem. This was the first problem which we were considering. I have been asked to speak a bit about my achievements. Well, I have no reservation to speak that it has been entirely through my students, past, present, and future to come. They really have shaped me up as I am now. In my profession, as per my opinion, the greatest advantage is that we need to interact every time, and these interactions teach us more. The angle at which I view a particular topic or problem in physics may have an alternative approach. Discussions with these bright, young and intelligent minds have paved ways for me to learn physics more. In this context, I would like to remember a famous quote by Henry Poincaré. It goes as, "A scientist does not study nature because it is useful to do so. He studies it because he takes pleasure in it. and he takes pleasure in it because it is beautiful. If nature was not beautiful, it would not be worth knowing and life would not be worth living. I am not speaking, of course, of the beauty which strikes the senses, of the beauty of qualities or appearances. I am far from despising this, but it has nothing to do with science. What is meant is that the more intimate beauty which comes out from the harmonious parts of the order of nature and which only a pure intelligence can grasp. This is the particular philosophy that we always try to inject within the young minds and also have been successful many times. We in our college get students from every corner of the state as it is located in a prime location in central Kolkata. They have really a variety of backgrounds, rural or urban, economically weaker or privileged section, coming from English or vernacular background, national boards or state boards. Catering to them individually is quite often a challenging task, as because everyone has a different perspective and a different problem. But I enjoy every bit of it, as this helps me to understand the philosophy of life more and more. There is another quote which I want to share. No student is mediocre, only their ambitions are. As a mentor, I always advise them never to lose hope under any circumstances. That's because I feel the same kind of happiness when someone informs me that she has finally secured a government job, even as a lower division clerk, or when someone just comes into the department to say hello before moving out of the country as a postdoctoral fellow in one of the renowned US universities. I get a big sense of relief that yes, they are finally secured and they're happy. Though not strictly included in the UG curriculum of the University of Calcutta, I have pestered students to take up reading projects, while sometimes going beyond the syllabus. They need to consult books, journals, web resources before submitting a written project and presenting a PowerPoint to the department. This has been immensely helpful, not only to motivate them to research, but also to boost up their confidence level and public speaking skills. I have been an invited member of the UG Board of Studies, University of Calcutta, during the revision of the physics honors syllabus in 2019. This is because I had vehemently raised voice with the problems that arose during teaching the 2018 syllabus to students. I am happy that I could finally communicate the problems to the honorable members of the board and amendments were made accordingly. I have something else to share. I have a dream project of myself to set up an astrophysics research center in my college with a full-fledged observatory. Currently, I am working upon the modalities of the same. We had inherited 2-century-old astronomical telescopes in our department, which were made in Caddy, London. They can be used along with a possibly newly procured one. It is where my students of my department and also of nearby colleges can come to work upon dissertations. As an extension, I have planned to offer a certificate course in astronomy and astrophysics. Obviously, it would be funded by UGC, and also we use the facility for an outreach program for high school students, as because the more students come into basic science, the better it becomes. My CV contains all my detailed credentials. Last but not the least, I need to mention that I might have been a full-fledged researcher if I really had wished, with loads of publications, citations, age indices, etc. I would have been continuously associated myself with my group at VECC, have my name published in every paper, but that would have taken out chunks of quality time that I spend with my students now. Being a teacher, I think it is my primary duty to cater to them first. Everything else may come later. With loads of teaching assignments in honors and general classes, examination and administrative responsibilities, I just couldn't afford time to be in active research. And truly speaking, I don't have any regrets. It feels quite satisfying for me to find all my efforts bearing fruit nowadays. My department is flourishing in every aspect, as it had to be talked about and taken at par with all the so-called good colleges in the city. All possible facilities extended to students, good results and vibrant placements coming year after year, and so on and so forth. So I think my decision to take up teaching so far has been the best that I have taken in my life. Even to this day, after 23 long years, I feel the same kind of thrill when suddenly the commotion stops in the class and less understood topics become clear. The deep satisfaction which I feel to resonate with my students at that instant of time is beyond comparison. I'm just thankful and fortunate that I am always being paid for what I love to do. After all, I'm a teacher. I can touch lives individually.